annoying and I've been erasing it manually. But I just want to know, is that something that I need to do, or is that
No,
not
actually, the
necessary?
white space doesn't matter in HTML, JavaScript, or GLSL. Both of them, they ignore white space. The indentation
Okay.
helps you to read the code properly. The only way to ensure that the codes will be opened in different editors properly is to make sure that the tabs are converted into spaces. Otherwise, if you spend a lot of time customizing your code and you open it in a different editor, you see that everything is just messed up. And the reason is that the tab space is indented differently in different editors. But if you convert tabs into spaces, like what I do, usually when you open it, almost always when you open it in other editors, it will always be properly indented. You can also, if you know what is the tab spacing, you can try it. Some people like to have tab spaces at 6 characters. Some people like it at 4 characters. Some people like it at 8 characters. There are some crazy people who use 2 tab spaces, 2 characters for the tab. It makes the code very compact. It's a matter of preference, but 4 tab spaces is pretty common. And in Vim, you can say expand tabs, and it will expand all the tabs into spaces. So wherever you open it, it will be the same number of spaces. But as you are editing the code and you press tab on your editor, if you haven't set the tab space to be 4 spaces, you probably have a hard time following my spacing. My tab spacing is 4 characters per tab. That will help you if you want to follow the same tab spacing. Fine. There's a tab
No,
space and tab stops at 4.
it should be fine. It's just whenever I do a new line, it likes to tab over by 2 as a default. So it's not going to bother me. I just want to make sure when it syntax errors.
Okay. No, the syntax is fine.
Your entire JavaScript file can be 1 line long. That would be valid syntax. So you can get away
Yes.
with a lot in terms of spacing.
Actually, a lot of that's a very nice point that Max is making. A lot of the big library developers or people who are really worried about the speed of loading a page is that after the development code looks exactly like what you see here. Not exactly, it's something similar to what you see here that is spaced and it's nice so that you can read it. And then there are programs that actually remove all of those white spaces and they change it into just a single space so that there won't be multiple unusable characters. So you see that usually those ones are ending with min.js, meaning that or the code is minified so that the spaces are removed and the file size becomes much smaller, so the loading is faster. So after you develop the code, you can minify it if you want to put it online. And there are multiple tools out there. There are scripts, there are code minifiers online that minify your code. So that removes all these spaces, as Max said. Okay, any other questions? No? I have an OCD that the trash can should be always empty, so empty that one before we continue. Okay, let me see if the code size, is this size large enough? Maybe I should make it into 2 pans before I start modifying so that we know. This one off. Looks good.
Yep.
Both windows can be read easily.
Looks
Okay,
good.
so this is, I think, the last code that we were working with. And I talked about this fact that in the run loop that we had, basically this plotting was the bottleneck for the calculations. And what we did to get around it was to march the solution for several time steps. In this scenario, 4 time steps, because each of these march instructions is actually marching the time step for the solution for 2 time steps. And you can actually play with this in the middle of the calculations, and it's easy by adding a variable into this structure. Let's say call it a skip and put it as 20, and then in your instead of here reading the number 2, it can be environment.skip, so that it's always reading the value of that. And you can add something to the graphical interface, that instead of that you can type the skip and remove the listen part anymore. And if you do that, then you see that you can actually load down the solution. And let me change this one to false so that we can start it on our own. I'll show you that how much you can change the solution speed. So this is the initial one that we're calculating, and we can go much faster. So that's the first thing that we changed. And you notice that in the previous sessions we were assigning, we were just looking at an event whenever this one was changing, and then we were updating some of this stuff. And the reason that here we are not doing that is that this JavaScript section, the main script that you see here, and I wrote, I think, a comment somewhere that this is in JavaScript language, which is on the CPU side. I don't know why it's unhappy about that. I think it's because of those 2 lines. It's on the CPU side, and the moment that you change something, right now it's getting sad about the syntax highlighting here. But the moment that we change something through the graphical user interface, this variable in the environment is changed, and this location that we are reading it is actually reading the updated value. So everything is on the CPU side. We don't need to inform anybody of this event that it has happened. It's always using the updated value here. But whenever we were changing something into the variables that were sent to the shader, we had to inform the shader of that change. So we talked about this, that if, for example, we wanted to change the delta t, we added, for example, a section that is able to change our DT. By the way, you can set steps for this, that is changing by, for example, every step of 0.001. Whenever it was changed, we had to inform our 2 solvers of that change by calling this function that we are writing in place, that our thing is called fmarch, is first step of the march. In the uniforms, the variable dt, we have to change its value to the new dt value on the CPU side, and we had to do it also for the S solver, because there were a pair of solvers that were having the same sort of input. So right now, if you do that, then a dt is added there, that you can change it to maybe a smaller value. You run it, and then and you would see that the new DT is picked up. Change the DT. Okay, so the reason that we had to inform is we have to send the information to GPU here. And these instructions that you see in these lines is basically informing the GPU of these. Okay, so on the next objective of today was to use this variable time that we had inside the shader to maybe do a little bit of changes here. So let's say we wanted to paste every 200 millisecond in the corner. We wanted to change the U. The first thing that we had to do was to make sure that we are updating the time variable. Remember, this time variable is actually part of our texture, and it's different from this environment time that we are using, we are updating here. This is updating a color channel in our texture, that how much time has been lapsed from the beginning. We started from 0. We want to say if this time variable was greater than, let's say, 200, every 200 milliseconds, we want to change U to 1, only if we were in the corner. Maybe the length of CC was less than 0.1. Only in that scenario, we want to change U, to change time, and whenever we pass 200, we want to reset our time back to 0. This is basically our pacing algorithm. Let's see what happens. We can also change our initial conditions in the init shader. So remember, this was the init shader. This was the part that we were setting something, an activation in the center of the domain. And set everything to 0 now. Change, we start running. Every 200 milliseconds, we are pacing from the corner. So now you see, if I wanted to see what is the behavior of the system if this pacing period was changing, I had to probably bring something in the form of a uniform, like float, and say the period of the pacing that I want to do. And instead of this 200, I had to use the period here. And then go into the initialization section, probably define a period section here as 200. And then as I change that, I have to go down a little bit further and add this period to my solvers, right? As the new value of the uniform. But I had to do the same thing for this guy over here, and I had to remember that I have to do that. And then go a little bit down and add this period to my graphical user interface. So I copied the code for that. I just changed this one to period, and change these DTs to period as well. Guys to period as well. So both of these guys were changed. Sorry?
On the step 2, right? You're on 1.01.
Yeah, you don't want probably 0.01. You want to change it maybe every 5 milliseconds. So now you can change it, make it faster, faster, and faster. 165, you would see conduction block. And I see you're getting conduction block. But this process of maybe the adding it to the graphical interface wasn't too bad, but if you miss this part of writing these lines, multiple lines to both of the solvers, basically makes your code larger and larger unnecessarily. And the only thing that is different between these two solvers were basically the textures that were going into them. All the other stuff for them should be basically identical. So, and you can see that this uniforms that we are sending is basically a JavaScript object that we are sending in that has different fields, the object, and each object is also another object that we are sending in. So instead of sending this, we could, for example, this is a better way of defining the uniforms for these sets of solvers whenever you are writing a model that you have to do a time marching, and only just a couple of them are different, and you want to add multiple things through the graphical interface. You can write a function like marching uniforms, like so. It gets an input as input texture, for example. This part that it's doing is because I usually don't write the code like this. I could have a variable uniform inside that it is equal to, I could copy the entire thing that I have here to this guy. And then return the uniform. And instead of this F color, I could turn it into in texture. And instead of calling this entire thing here, I could call that function marching uniforms. And I could pass F color here. And do the same thing for the second set. The only difference was that for the next one, I have to write it as S color. So now if I want to add more uniforms here, like for example, I want to pass A, B, epsilon to that, I don't have to write it into multiple locations. I add it into this uniform section and it will be passed to the solvers appropriately. There is no way that I will forget that I have to pass it to both of these solvers. So let's see if it works. Working.
By the way, just one quick question. I don't know if everybody follows what is conduction block, what is happening. Anybody has a question on what was happening when he's pacing too fast? Okay, you're just getting, it's every other beat gets blocked and only every other beat gets passed through. Okay, thanks, Hamza.
You're welcome. Thank you, Flavia. Talked about adding the uniforms into that data structure. If at any point you see my codes, you would see that this is the structure that I like more that is actually defining a class uniforms in texture. This is another way of doing the above method. All of these ones are more or less equivalent. And the difference is for this one, I copy this entire thing. This next one, there is this keyword before this. There's instead of these commas, you say that you want to redefine these, you want to define them as that line that you see there, and everything ends in a, sorry, everything ends in a semicolon. And this one basically defines a, you can return, this last line is optional, return this. And the only difference is that if you want to call it with that, you have to use the keyword new. Basically, it creates a new object that is defined like this. Inside the object, the in-texture property of the object is this this object here, and the DT part of it is that object, and so on and so forth. So depends on how you want to define it. It's a little bit different. Some people are uncomfortable defining it like this definition here, because you're using a local variable, and local variables usually are destroyed after the function is done, but you're passing the value of it. And when you're passing the value in JavaScript, basically a pointer to that location is passed. So there are lots of internal things that are happening here, but which on most of modern browsers is fine. But this is a more classical definition of a new object. Did anybody have a question?
Yes.
Yes.
So I've seen that whenever you write in texture, whenever you define that, you always use underscore in texture. Is that a style choice, or is that required by the code?
No, it's a style choice.
So that
This is to basically the underscore here signifies the fact that this is a dummy variable that is going to be replaced by something else. You can write anything here, it doesn't matter. Even if you write fcolor here, the value of fcolor will not be passed. It will be just a dummy variable here. But to signify that this is a dummy variable, let's choose a different name for it.
That's just for the coder's purposes, right? Not for the execution.
But not for the execution. You can change this one to anything, any variable that you have. You can change it into, again, fcolor, and pass fcolor here. This will not be the same fcolor that you have in your code, and you can use the same definition that we had here. I can pass the next one here. It's a bad practice to do it like that, but it works. Or maybe it doesn't.
Got it. That's fine.
Oh, there should be a new keyword here.
So while I'm asking questions, so I have also observed in one case that when you skip the time steps during the, let's say when you're trying to increase the frame rate, is it the same thing?
What do you mean?
So when we change the frame rate of a code, does that affect the output of the code?
No, the computations don't change. The only thing that changes is basically how often you are plotting your results to the screen.
Okay.
So what you are calculating doesn't change. What is calculated is just stored in the textures, and the time marching it's not affected at all. What is changed is how frequently you are writing the results into the screen.
And the thing is that it speeds up because now you don't spend time writing on the screen. So
Yes.
that's why it accelerates. The speed is the same, but it slows down if you put prot a lot.
Yes.
And the reason is that the refresh rate of the screen is 60 hertz, and you can't draw anything more than 60 hertz on most of modern displays. Some displays right now can refresh up to 120 hertz, something like that. You see that some expensive displays are coming out that they can refresh the screen faster. But if you wait for the screen to be refreshed, because you see what we are doing here, you're using this request animation frame, and this will not run until every plotting request that we have sent is finished. So it will not be calling this run again to go through this loop. So the results won't change. The only thing that changes is how often you plot. Yes.
I'm asking this because while I was doing one of my simulations, I observed that if I increase the refresh rate, the simulation suddenly changes. So maybe I'll send a video after the class and you can have a look at it.
What can change is, okay, so whatever is making the decision, if it's inside this time loop, it won't be affected. Whatever happens after this time loop, after this number of escapes, if I'm doing it outside, it will be affected. So there has been times that I have made some of the decision making outside of this part because I didn't want to spend too much time on those decision making parts. And if you increase the frame rate, definitely those ones will be affected. So I think you are referring to the O'Hara-Rudy model, which has a ton of stuff inside the loop and then a ton of stuff outside of this loop. And those ones that are outside the loop, they definitely change.
Yeah, I could notice that because in one case there were no spiral waves, and in the second case, when I increased the frame rate, suddenly the spiral waves appeared. So that was a dramatic change there, just because of the frame rate.
Also, I think that at some of the points you have increased the frame rate to an insane amount. So if, for example, if I increase this one to, I don't know, 500, then you see a lot of the stuff in between are skipped. And if I go to 2000 now, I don't see a lot of the stuff that is happening. It seems that it's stationary, nothing is happening, whereas actually a lot is happening.
Yeah.
If I slow it down, I can see what's going on, but if I increase it to that amount, basically it won't be refreshing anything, and a lot of the fine features that are happening, you will miss them, and it will appear as if something out of nowhere appeared on your screen. I think you can see it on that example that I have, that I'm clicking on the screen and we are generating new spiral waves. Okay.
Yeah, thank you.
Okay, so the last thing that was requested in the previous session was you requested to see how we are implementing the interactions with the graphical user interface. So when we want to do the interactions with the graphical user interface, what we need to have is a bunch of stuff. Is that first we need to be able to record a click, and when we record the click, we need to know where the position of the click was. The click event should be recorded. And then, based on that, we need to do some decision making that, for example, a radius around this click, I want to send out excitations. So we need to have some sort of a radius R that based on that click, we are doing some changes. So what's happening is that the clicks happen on the canvas, and your data structures are in textures, right? So your data is stored in textures. Click happens on the canvas. Data structures are stored in the texture. And the way that we can manipulate the textures is through solvers and shaders. So you have learned how you can do a time stepping algorithm. The next thing that you want to have a solver that gets one of these textures and changes some of these pixels. Changes some of these pixels. So maybe gets F color as the input and writes a new S color. But this can happen in the middle of the simulations. So we want the changes to be applied to the S color as well. So maybe we want to just copy the results of this S color to F color to make sure that the changes are applied to both of them, because we don't know when the click is exactly happening. Is it happening after the F march, when the next thing that we are going to run gets the S color as the input, or is it happening after the S march, where the next step that we are going to do is the F color as the input? So both of them needs to be updated so that the event is handled correctly. So the first thing that you will need to have is to have a solver that is able to get the click position and the radius of the click, as well as your input textures, and update them. So what we are going to do is I'm going to use this solver that we had before. I intentionally separate this to a different solver. I copied it now. We have the two copies. I can remove the additional parts. I don't need about delta x to know about delta x. I'm not going to do any Laplacian or time changes, nothing. I don't need to know about the diffusion coefficient or period. The only thing that I need to know is the pixel position and the input texture. Probably two uniforms that are going to come from the solver. One is a vector 2 type, my click position. And then there is another one uniform that is of type float, that is my click radius. Okay. I can start writing a new solver based on that, and make sure that you change the ID to something else. Click so that we can access the source code for that part. And then we can write the source for the click solver. I have a new solver. That has a fragment shader. The source has the ID click. and as uniforms, it is receiving an in texture that is of type texture, and its value is maybe of color. And then you have a click radius that's coming. Type is a float. Its value is, let's say, 0.1. And then click position that is of type vector2. Its value is, we haven't clicked anything yet, but we can send some number, miscellaneous number, because until we render it, nothing is going to happen. By the time that we are going to render it, we are going to update this click position to the appropriate value. And maybe we can write it somewhere above the run and march algorithms, below the march. And then the targets, I can just copy from the other one. We are going to write the scalar. The internals of the code is very simple, is that whenever the distance of the center of the pixel is from the click position is less than the click radius, we want to change u to an excited value, let's say 1. Otherwise, we don't want to do anything. Whatever color we got as input, we just send it as output. And this step that I mentioned, that the scalar needs to be also, so what this solver does when we call it, it takes the fcalar, decides whether we are close enough to the click position, and we change it to the excited value, and we write the scalar. We want to make sure that this value is copied to the fcalar as well. So what we do is that we are going to use an algorithm to copy, and the copy part, we can call it click copy, and we use, because many times in computations, you just need to copy one texture to another, the values of one texture to another. So I've written a simple program for that, which gets the scalar and writes it on the fcalar. And then the next step is to basically define the event. Remember, we wanted to be able to determine where we are clicking. Rather than clicking, I'm going to implement a drag, but I can show you what you can do to clicking. So I want to be able to excite a region based on a drag. So I can have a mouse drag. You can name it anything, my mouse drag or whatever, doesn't matter. In fact, you don't have to actually store it anywhere, but new mouse listener. But this one listens for mouse events. The reason that I'm using this is that sometimes the click events based on the elements that you have, locating the click position can be a little bit tricky on different browsers. But this function basically does it for you. So you want to say which canvas you want to look at. So we want to look at canvas 1. And the event that we want to listen for, and is a mouse drag that we are going to listen for. And whenever the event happens, you want to have a callback that sends the event into this function. And the information that you have in the event, one of them is the position of where the event happened. So in the uniforms, this is the important part that happens. Uniforms of that click solver that we defined above, we want to update the click position's value to the click position of the event. So we update the click position of the solver by the click position of the event. So we send that information to the GPU basically. And then as soon as we have that, we can render the click, and we can render the click copy to make sure that both of the textures are updated. That's the function that we are going to call. If everything went according to plan, I update this page, you see something. Click copy was not defined.
Is click copy a function?
Oh, I have to render it, sorry. It's a solver.
All right, cool.
Actually. Now I can see you can drag it. Maybe you can make it a little bit smaller, so it's not that big. Half of that is more appropriate. You can run, and you can see you can have excitations, and now you can actually interact with the solution that you had going before. And you can create spiral waves using this method pretty easily. But the point was that you can actually interact with these parts, and the function that I wanted you guys to see was this mouse listener that returns the click position for you. So right now we were updating a click radius and click position in a solver that was doing something. But later on we will see that we can use it for picking up where we are looking, and we are reading the signal, for example, in this solution here, where we want to click and see what is happening at that particular point, probably get a trace of the voltage, for example, or one of the variables. If you don't have this part, it may still work. Sometimes it works, sometimes it doesn't work. The reason being is that it's not working correctly. The reason being is that everything is asynchronous, so you cannot guarantee. On a different browser, if you try it, it probably may work. Sometimes it may not work. But if you write if you update both of these textures, you are not relying on the fact whether you are clicking after the first call or the second call, because these events are called asynchronous to what is happening on the other side. So I've noticed that the easiest part is to just write a copy part that is doing the same thing separately. One question that you might have at this moment is that why didn't I create a second channel here and send that one as like the second color, maybe the first color and the second color, and then output them, first color and the second color set, and say that this one was the S color, maybe this one was the F color, and update both of the textures at the same time. Why didn't I do that? So let's try to compile the code and see what happens. There should be a comma here. I want to have a reasonable chance of compilation. This O color needs to be maybe F color, and get rid of the syntax errors. Bunch of warnings happened. It's not trying to show me. Okay. So actually, if you allow it to write everything, you will see that there is some sort of a warning here that tells you failed to load source map. That's not the same one that we had before. I don't know why it's not throwing the error here. But the reason is that usually if you just had one, I mean, let me see if this one gets me into trouble. If I just had one color as output, and I was reading the same texture and writing the same into the same texture. Oh, I had to call the click. So this color, the first one was fine. The second one, which is the second color channel, try to do it again. You try to basically, if you try to run this channel, you see that you get an error, WebGL error, that says that the source and destination textures of the draw are the same. And WebGL doesn't allow you to do that to protect you from accidentally starting to have competition of data. If you are reading from a texture and writing to the same texture, everything is happening in parallel, right? So let's say you have this texture here, and your GPU is updating everything. Your GPU is updating everything, and you update this point, and then your neighbor core tries to access this point here. So instead of having the previous value, now it will have the updated value. Next time that you are calling it, maybe this core didn't get to finish its job and it's not updated yet, and you get the previous value of the code of the pixel in this code here, in this core here. And that would lead to really bad behavior that you would never understand why each core is doing what and why you are getting different results each time that you are running the code. Usually in other languages like CUDA, you can actually update the neighbors. You can access to all of these data, and you have to be very careful of what you're doing so that you don't accidentally start updating something or assume that an update is actually finished. In order to remove any of these problems from the parallelization, WebGL doesn't allow you to have the same texture as input and as output. The moment that you remove this S color from there, it starts to get happy again. You won't have any of those errors anymore. Start drawing on the screen and interacting. So we can't update both of these textures at the same time. There's no way until either a third texture is introduced, so that one of them is the input and the two others are the output, or we just use a simple copy. And anyway, this clicking algorithm is not that time consuming, so you can easily interact with the code with no performance issues. A bit faster, interact with it, very therapeutic. Okay, I think it's a good point to stop here and see if you have any questions.
Thanks, Abdusar. This is pretty good.
Yeah, thanks. That was really cool.
You're welcome.
I have a question.
Sure.
Is there any reason why, like, okay, yeah, I see you're using a like custom abubu.js mouse event. Is
Mhm.
it distinct from just a normal like mouse listener that you would put on a canvas in regular JavaScript?
It's actually inside of it is using that. The part that is happening in the library is extracting this position. So it's still
Okay.
using the event, is just extracting the position and returning a value between 0 and 1 for the X and Y values of the event. If I
Oh, right.
go maybe to you go to the library itself.
Because a normal listener, I think,
Open
would
the
give
source
pixel
file.
values, if I remember right.
It gives you the pixel values sometimes, and then there is the problem of that the click event actually returns. Even if you put it on the canvas, the value that you get is the absolute position on the page. And then if you have content above the canvas and you are scrolling, then it's a nightmare to find out where actually the click is happening. I have actually customized this one a lot to make sure that the results are correct, and every once in a while I still see that the result that I'm getting is not really consistent. So let me see. I open the library here. The I think it's called mouse event listener. I think it's called mouse listener when I defined it. I outputted it as mouse event. Mouse. Yeah. It checks out the keys, and then you see there is some sort of a loop that at some point I go through. I don't remember this. I did it correctly. See, there is there is a loop that you have to go through to determine whether you found the correct U and V positions there. So this section is actually in charge of doing that, and I have been using the click in a lot of the codes. And every once in a while, I used to find a bug in the code that if I wanted to fix, I had to go back and change everywhere in the codes. So what I did, I put the listener eventually inside this function so that it would be easier for me to deal with it. Also, you can have additional events like shift click, alt click, control click, and meta key click. So if you're implementing for a Mac, there are different keys that you can press, you can implement. Yeah, mostly it's because of this loop that constantly I have problems with determining that. And then I decided to put everything inside the library to make my life a little bit easier to deal with just this E position. And if there was a problem, I could solve it in one place, not in like 80 different codes.
Okay. If the texture isn't like a one-to-one with the canvas, like it's projected onto a 3D image or something, will it still find the right place on the texture? Or do you have to do something extra for that?
So we will talk about the 3D events. The 3D events, you have to actually if you want to find out what is happening in 3D, is actually the complex problem that you need to solve.
Okay.
So this clicking that you see that I could do to excite the tissue, it's in the end, it's a 2D image, and you have to figure out where in 3D space you clicked. And that figuring part was one of the parts that can be actually a little bit challenging, and it has to pass through a couple of shaders to determine where the location of the click on the geometry is. And that one is actually one of the ones that was really necessary to implement it in the volume raycaster itself. So this one is a complex problem that if you want to solve it, not really complex, but it's time consuming. You don't want to spend your time doing that. Time you're writing a 3D code.
Yeah. So is there like a helper function in your library that does that, or is it something you have to do every time?
If I show you the source code for that, is actually for the 3D codes. Maybe matter. So for the 3D ones, we will next week probably go to the 3D. In the volume raycaster, let me see, where is my click event? I define the click here, which needs a lot of input. And the control click is actually getting the updates the click position. There is a variable inside the volume raycaster that is returning the click coordinates for you. So you can pass a click position to the volume raycaster that we have, and it will return a click coordinates for you in 3D space. And then you can use that click coordinate and you can pass click radius, click values, and whatever you want to do with the click later on. But the volume raycaster is the one that you pass the click position to it, and then it will give you a click coordinate basically in 3D space for you.
Okay, cool. Yeah, that's convenient.
But the clicking part in 3D, you have to do a little bit of extra work when you want to find it. In the most simplistic term, is that in the end it comes down when you have the coordinate. it becomes the coordinate instead of this point. Coordinate of the voxel minus the coordinate of the click. And then again, less than the click radius, we change something else. Any other questions?
Question. Can we save the state of execution or just the texture so that you can just start with a given texture every time? Let's say you want to see how a certain situation changes and parameters change, and you start from the same place every time.
Yes, so we will talk about saving textures and those ones a little bit later. How we can copy the textures back to JavaScript, and you can actually import them later on if you're interested. Anything else? No? Stop the recording.